Hi everyone. Today we start new subject calculus for business. Firstly, let's introduce something to that subject. Calculus for business has 3 credits. You can read the subject objective, the textbook, and the way to finalize score in my slide. More detail. The final score will be consist of 3 columns. First, the project or class test 20%, with exercises activity 5%, the midterm test 25%, and the final interim test 50%. Now, let's go to the first lecture, function, which has 3 small paragraphs. The function we introduced already at high school, so I will not repeat there. We will focus to economic functions. Firstly, the simplest one, linear function. The linear function, I can recall, we have 2 pictures. First, the form y equal ms.b, where the number m is called slope. And second, the graph of a linear function is a straight line. In a lot of economic situations, we meet linear function. For example, if we open one multi-shop, so the cost of that shop will be consist of 2 sections. First, fixed cost, sometimes we say overhead, some constant, related to rent, design, furniture, or salary. And the second, variable cost, it depends on how many multis you sell for one day. And the total cost will be the sum of fixed cost plus the variable cost multiply the unit. Let's see example 1. 1. Manufacturers has the total cost consist of a fixed cost of $200 and production cost of $50 per unit. So if we note S, this is the number of units produced. The total cost will be the fixed cost plus the variable cost multiply the number of units. That means 50s. So here you have the linear function. Another very important feature of the linear function is rate of change. If we have one function, and if the variable s changes from s1 to s2, so you have the change in s, delta s, the change in y, delta y, equal fs2 minus fs1, and the ratio between them is average rate of change. When we have different functions, usually we have different rate of change, but only the linear function has the rate of change constant, and this is the slope m. Let's see another economic example. Since the 1st January, the price of a bottle of soda has been rising at a constant rate of 2 cents per month. By 1st November, the price is $1.56. Express the price respect time. Find this price at the is always constant rate. Next, by 1st November, that means S equal 10. You have the price. This is 156. We find easily B equal 136. So finally, the function we ask you is that one. And at the 1st January, we set S equals 0. So the price is 136. That means $1.36. After linear function, the next important function is quadratic functions. This is the second degree function. Here we like to recall two features. First, the graph of that function is parabola. So we have one vertex, and the location of the vertex S is on y minus b over 2a. And the direction of this graph, the parabola is upward when I positive and downward when I negative. Now, let's use the quadratic function to solve the next example. When S hundreds units of some commodity are produced, they are sold for a unit price given by the price B equals T minus S dollars. At what level of production is revenue maximized? We can guess the revenue. We note A. This will be the price multiplies the quantity. So substituting B equals 60 minus S, you will have the revenue function is that one. So this is the parabola, and the graph will be downward with the size here negative. And as the graph is downward, you see the vertex will give us maximum. And as here this is minus B over 2a. So you get 30. But the real answer is not 30 because it's S. This is 100 units. So the answer will be 30 multiplied 100. So you have 3,000 units. Not only linear or quadratic, but also a lot of functions can be met in economics. The most basic will be first the price. The price P depends on the quantity. When we have a lot of quantity, usually the price will decrease. For any manufacturing, we can find the cost function like total cost when S units of some good is produced. By selling this unit, we get the revenue. So revenue, this is the quantity multiplied the price. And finally, the profit function will be revenue minus cost. Let's say example 4. Consumer will buy S1,000 units of some kind of coffee when the unit price PS is given B. Quantity multiply price. And when we have revenue and cost, you can find the profit function. The profit function will be the revenue minus cost. You can get some simplification and we will find the revenue, the profit. Here is minus 2.5 square plus minus 85. If we want profitable, so we that profit positive. And so on the second degree innovation, you will have S from 2 to 17. Finally, let's discuss fast some review question. Question 1. If we have fixed cost and variable cost, how you can find the total cost? You must remember fixed cost plus variable cost multiply S. So the answer will be I. Next, price of some share decreasing with constant rate. When you see constant rate, you think about the linear function. And S decreasing, you will have the slope here negative. So the price after S squared, you see here we have two linear function, but the slope is minus 5, so the answer is B. Question 3. Which function is quadratic? Quadratic is a second degree, so between three functions we have only B. 4. When S,000 units is produced, on will be shown for the unit price B equal that one when revenue maximized. So this is similar to previous example. You have revenue, this is a quantity multiplied price. So the graph here will be parabola and you will find the maximum. And the last one, consumers buys S unit with unit price and the cost is given to find the profit function. So repeat the previous example, you will have the profit function is the revenue, that means the quantity multiplies price minus the cost function. Thank you for attention.